Okay, so where we're at historically is kind of where the ancient cultures were a long time ago, right? They had, this is a much easier thing to work with. We know there's a way to go from general to standard, but that method gets a little hard and crazy at times. So is there an easier way? And it turns out that there is. First of all, the idea is if I can find out what h is, the k value is basically what f of h, right? That's just what I'm basically using there, is that if I know the input, I can find the output by plugging the input into the function. Okay, so there's basically how we're going to find the k value for the vertex. So it really comes down to, can I find h? If we can find h, we've got it made in the shade. Because once I have h, I plug it into the function, I find my k, right? Because that's just what happens functionally. You give me x, I'll put it into the function, find you y, and in this case we find the point hk on the graph, right? Here's the input, here's the output via the function. So it's all about finding h. So what we're going to do, right, and I don't know who came up with this. Again, I think it was the ancient Babylonians. You can blame them. Okay, they said, well, why don't we just go ahead and modify, complete the square on just the a, b's, and c's, and kind of see what comes up. So check this out. So we begin, right. This c we're going to leave out, and we're going to put some parentheses around the pieces that are interesting. And we begin by factoring this a out because I want a leading coefficient of 1. But when I do that, that now creates this fraction on the back end, and then plus c. So keep in mind, if I redistributed the a times x squared is ax squared. The a's will cancel out, leaving us with bx. So mathematically, I'm fine here. This piece right there represents the incomplete square. So we take the b over a and we divide it by 2, right? Or written another way, that's b over a divided by 2. Of course, if we divide by 2, that's the same thing as multiplying by a reciprocal. So we end up with is b over 2a. So put your cap on that. What do we do with that? We take that value and we square it, giving us b squared over 4a squared. So here's the piece that we need to add, and here's the piece that's going to help us factor in a little bit. So we get a x squared plus b over a x plus b squared over 4a squared, and then we're going to subtract b squared over 4a squared. Okay, so as we've seen, this piece right here was there to balance off this addition. Add it, subtract it, the net effect is 0, but we eventually want it to go out of the parentheses, but it's being multiplied by a. So when I do that, right, what ends up happening is this a cancels out with one of these a's, and we get negative b squared all over 4a and plus c. All right, and here this actually factors. This factors as a x plus b over 2a, right? That guy right there squared, and then let me write that as plus c b squared minus 4a. All right, and when you take a look at this, what I have is essentially the vertex formula. This plus b over 2a means that we're actually shifting to the left b over 2a units. So what this is telling me is that h is negative b over 2a. And that's pretty much what we're looking for. I now have a formula, right, for my h coordinate. And then to find k, I basically find the value of the function at that h value, negative b over 2a. So that's how you find k. Although if you want, here's your formula for k. So you have two ways. I like to use this, but there's another one if you just kind of follow my work. And so that's the big guy right there. So here's your vertex formula. You find h, plug it into the function, you find k, or if you're sadistic, I guess you can use that formula for k as well. I'm going to stop there. We have our vertex formula that we want. Let's go use it. All right, and of course I'm going to do that in the next video after all that groundwork. See you in a moment.